test stand is a test stand to estimate the modal damping by vibration measurements of so-called shims. Shims are materials which are useful for car brakes to avoid, for example, brake squealing or other issues. This test stand is a test facility which allows you to do most of the measurements automatically. That means you don't need any blue workers or any other stuff to fulfill the measurements, which are normally very time-consuming and therefore expensive. On this test bench, we estimate the modal damping from the free vibration or test object. So that means we need some excitation. In this case, it's a modal hammer, an impact hammer. We have also measure the force. So that's the excitation. The free vibrations we measure with a laser Doppler vibrometer, and as we want to do all the measurements according or depending on several temperatures, we also have to measure the temperature. All those units we are using are working non-contactless. This is very important because any influence on the free vibrations would have influence on the free vibrations and therefore on the results of the damping values. So we have an excitation, we have the laser micrometer. For sure we have to measure the vibration, we have to store, analyze them, and finally some tricky algorithms to get the damping. The shims as used in car industry, they must be measured. Damping must be estimated in a temperature range between 130 and minus 30 degrees. So the procedure starts that you heat up or you cool down your test objects. If they reach the final temperature, you get them out of the heater, of the oven or whatever. Place it under inside the test bench. Let's say shift it in the right position so that the laser and the hammer hits your object on the right place. And then you just press start. The temperature is measured online, so without any interruption, and from a certain temperature list which you set up before, the measurements will be done automatically. Once the temperature reached the temperature out of the list, the measurements are started. The hammer does the necessary impacts, mostly 5 or more, to get some averages, and the vibration results are then stored into disk. Then the whole operation is going into somehow, let's say, a standby modus, waiting for the next interesting temperature, and the measurement starts again. The estimation of damping is nothing new. This is done for years in industries. But all these measurements are normally done manually. That means you have to do the excitation via hand modal hammer. You have to store everything manually. And therefore all those measurements are very, very time consuming. Even if you go for only a few temperatures, this may take hours. This test stand allows you to do the measurements automatically. So you just put in the test probe or whatever you want to have to examine, and the measurements are done automatically. So even if it looks a little bit more complicated to set up, the procedure of testing itself runs by its own, and therefore it saves time and money. Well, we are talking about vibration measurements, and therefore to set up the test beds, it's quite useful to have some knowledge about vibration measurements. But this is only for setup. Once the setup is finished, once the test bed is prepared, it can also be used by, let's say, blue work or, let's say, people. Because the task is you only have to put in your test probe, press the start button, and the rest is done automatically. So if you ask me again, is it easy to use? Yes, it is. In this application, we are using the bench for the evaluation of the damping values for shim probes. But in principle it can be used for any technical structures where during the development or let's say during the testing phase the damping is quite important. So if you have parts maybe in the aerospace industries, other parts from cars, in normal mechanical engineering, in medical areas, everything can vibrate and everything must be therefore optimized regarding safety and comfort. And so everywhere damping is very important for a successful, quick successful development, and also for simulation, the test bed can be used. There's no need for additional personal staff to drive the measurements, to watch or regard them. So the big advantage for sure is to save costs, to save time. On the other hand, the measurements are done automatically. So in comparison to manual excitation, here the reproducibility of the measurements is very, very high. So the quality and accuracy of the measurement data are much better than somehow if you do it manually by hand. The base for any damping estimation is the so-called transfer function. Once a measurement finished, all the transfer functions can be displayed in this diagram, mostly shown as an overlay. So here you see exactly whether all the measurements will proceed in the way you expect them. Then we are doing a so-called contour plot. This is showing you that the natural frequencies where we go for the damping are temperature dependent. So we are going for a peak picking. From this peak picking we can then estimate the damping values mostly by an algorithm for the so-called half power bandwidths, the -3 dB mostly well known. And finally we can show different displays like here this waterfall diagram which gives you your interesting damping value depending on frequency and temperature. All this nice contour plot. Here you see where we have these red areas. Here we got high damping and for this temperature and frequency range. This shim would be, let's say,